Let's talk about parallel and perpendicular lines in the coordinate plane. So instead of talking about corresponding and consecutive interior and all of those types of angles that we've talked about so far this unit, we're going to transition to talking about y equals mx plus b. Today we'll be using points and slopes to calculate equations of lines that are parallel or perpendicular to each other. So before we add on that extra layer of writing equations, of making them parallel or perpendicular to each other, let's just review what you should have learned last year in Algebra 1 as well as in 8th grade math, which is, given 2 points, write the equation of a line. There's 2 things that you need in order to write the equation of a line. You need to know a point on the line, and we have 2, so we're good to go on that respect. And you also need to know the slope of the line. In order to calculate slope, we use slope formula, which is y2 minus y1 over x2 minus x1. And the y2's and the x1's and all of that, that's referring to each of the points that you've been given. So I'm going to label my first point as x1 and y1, and my second point as x2 and y2. How did I come up with those labels? Well, the first number is always x, and the second number is always y. So it's always x and then y, x and then y. It's alphabetical. And then I just put 1's as a label on my first pair of x and y because it's the first point. And I put 2's on the second pair of x and y's because it was the second point. Labeling each of your numbers with an x1 or a y2 or whatever really makes filling in your slope formula a lot easier. So let's do it. I need y2 minus y1, so that would be negative 5 minus 10. And then I need x2 minus x1, so that would be 4 minus negative 1. Now be careful there, that's a minus minus, which is a plus. So if you'd rather write this as 4 plus 1, please go ahead and do so. Now that we've put our numbers into our formula, we can simplify. Negative 5 minus 10 is negative 15, and 4 plus 1 is 5. And I can reduce that fraction to get a slope of negative 3. So now I have all the information I need in order to write the equation of the line. Remember, I need a slope, which I know now is negative 3, and I need a point. I actually have 2 of them. It doesn't matter which one you use, just pick which one. I'm going to pick the first one, and I'm going to plug it into this formula. This is called point-slope form. So I'll be using negative 1 as x1, 10 as y1, and negative 3 for m. So let's plug in our numbers. Y minus y1, which is 10, equals m, which we calculated to be negative 3, and then open a parentheses, write x, minus, and then x1, which is negative 1. Here's another minus minus. You're going to see that a bunch in this lesson. If you feel more comfortable writing that as a plus instead of minus minus, please go ahead and do so. Well, now we need to simplify because our final answer should be written in slope-intercept form, which is y equals mx plus b. So to do that, I'm going to need to distribute. Negative 3 times x is negative 3x, and negative 3 times, well, that's really a positive 1, right? That's a negative negative, so it's a positive. Negative 3 times 1 is negative 3. And then just one more step to get to our final answer. Add 10, and I get y equals negative 3x plus 7. That is the equation of the line that has these 2 points. So let's go ahead and talk about the extra layer that we're adding to this compared to what you did in Algebra 1, which was just writing equations of lines like what we did on the warm-up. Now we're going to write equations of lines that are either parallel or perpendicular to a given line. If lines are parallel, then their slopes are equal. And if lines are perpendicular, then their slopes are opposite reciprocals. That's how we're going to be determining the slope that we need for the equations we're going to write today. We're going to be comparing the slope that we need to the slope that we've been given. If we're told to write the equation of a line that's parallel to a given line, then we'll just use the same slope that we were given. But if we're asked to write the equation of a line that is perpendicular to another line, then I need to use the opposite reciprocal of that slope. We'll talk about how to calculate an opposite reciprocal here in a second, but first let's discuss the formulas that we're going to need in order to make this happen. First, we need slope formula, which we used on the warm-up. That's just y2 minus y1 over x2 minus x1. We use this formula if you know 2 points on the line and you need to calculate the slope, or the rate of change, of the line. We're also going to need point-slope form, which we also used on the warm-up, which is y minus y1 equals m times x minus x1. x1, y1 is a point on the line, so you'll put those numbers in here and here. And m is the slope of the line, so you'll put that in here. Which means that this y and this x, the ones that don't have numbers on them, are going to stay y and x. You don't plug numbers into every single number in this formula. Some of them need to stay x and y because that's what equations look like, right? Equations have to have y and x. Specifically, we're going to be writing our answers in slope-intercept form, which is y equals mx plus b. So let's talk about opposite reciprocals. Opposite means opposite sign. So positive and negative are opposites. And reciprocal means the upside down version of the number that you've been given. Literally, it means to switch the order of the numerator and the denominator. So if I ask you to find the opposite reciprocal of 4, it can help to think about 4 as 4 over 1. Because since we're doing the upside down thing, we're turning the fraction upside down, we're exchanging the numerator and the denominator, it's helpful to have both a numerator and a denominator. And remember that with numbers like 4, any integer that doesn't have a denominator really does have a denominator of 1. So the reciprocal part of changing 4 into its opposite reciprocal is making it 1 over 4 instead of 4 over 1. But 1 over 4 is just a reciprocal. I need the opposite reciprocal, which means since 4 was positive, I need a negative for my answer. So negative 1 over 4 would be the opposite reciprocal of positive 4. Now let's talk about the opposite reciprocal of negative 2/3. Well, since it's negative and I need the opposite, my opposite reciprocal is going to be positive. And then the reciprocal is that I have to switch around my numerator and my denominator. So my opposite reciprocal of negative 2/3 would be positive 3/2. The opposite reciprocal of 9 over 8 would be negative 8 over 9. They're opposites because 9/8 was positive, and negative 8/9, of course, is negative. And they're reciprocals because they're the flipped version of each other. The numerator became the denominator, and the denominator became the numerator. The opposite reciprocal of negative 1 over 2 is just positive 2. If you want to write it as positive 2 over 1, so that it looks more like an opposite reciprocal, you're welcome to do so, but you really don't need to put something over 1. So they're opposites because one is a negative, one is a positive, and they're reciprocals because they're the upside down version of each other. The opposite reciprocal of 1 is just negative 1, because 1 as a fraction is 1 over 1, and if you change 1 over 1's numerator and denominator, then you change 1 for 1 and 1 for 1, so the 1 is still a 1 and the other one is still a 1, so many 1's. The opposite reciprocal of 1 is just negative 1. And the opposite reciprocal of negative 5, well, it's got to be a positive because it's got to be opposite, and it's going to be 1 over 5 because it's really 5 over 1, right? So if I make it positive, that's the opposite, and if I make it 1 over 5 instead of 5 over 1, that's the reciprocal. So let's put all of this information together to write some equations. We need to write the equation of the line that passes through the point negative 2, negative 6, and is parallel to the line y equals 5x minus 1. The only information I need from the equation that I've been given is the slope. And remember that the slope of a line, when it's written in slope-intercept form like this, is m, which is the number in front of x. So the slope of this line would be 5, and since the line that I'm going to write the equation of has to be parallel to this, the slope that I'll use for my equation will also be 5, because parallel lines have equal slopes. So to write this equation, I'm going to have to use point-slope form. In order to use point-slope form, you have to know both a point and a slope. That's why it's called point-slope form. And we know both of those things. We know that the point is x1, y1, negative 2, negative 6, and the slope is 5. So let's plug in our numbers. I have y minus negative 6, feel free to write that as y plus 6, equals 5 times the quantity x minus minus 2, feel free to write that as x plus 2. To write our final equation, it does need to be in slope-intercept form, so I'm going to need to distribute and simplify. So I'm going to rewrite that as y plus 6 instead of y minus minus 6. And then I'll distribute. 5 times x is just 5x, and 5 times 2, because that's a minus minus, so it's really a plus, 5 times 2 is 10. So the last step is just to subtract 6 from both sides, so the answer is 5x plus 4. This is the equation of the line that is parallel to this line and passes through that point. Let's try one that's perpendicular. So I have the same equation that I'm writing from, but a different point, and this time it's perpendicular instead of parallel. So I don't want to use 5 for my slope this time. I need to use the opposite reciprocal of 5. And then I'll be using 10 and 1 as my x1 and y1. And I'll fill that information into point-slope form. So my slope is the opposite reciprocal of 5, which would be -1/5. My point is x1, y1, that's 10, 1, so let's plug in our numbers. Y minus y1 equals m times x minus x1. So let's distribute. -1/5 times x is just -1/5 x, and -1/5 times -10, careful there, that is a negative times a negative, so it gives me a positive plus 2. Then I'll add 1 to both sides and get my answer of -1/5 x plus 3. This is the equation of the line that passes through the point 10, 1 and is perpendicular to y equals 5x minus 1. Let's try an example where instead of telling you an equation, I'm telling you a graph that your line has to be parallel to. Our line that we're going to write the equation of must pass through the point -7, 6, and it must be parallel to this line. So we're going to use point-slope form again to write this equation, which means I need x1, y1, which is the point that I was given, and I need the slope. And since these two lines, the one that I see here and the one that I'm going to write, they're going to be parallel lines, they have to have the same slope. To calculate slope from a graph, you just count your rise over run. So pick any 2 points that you want to. I'm going to pick this one and this one. And count the vertical distance and the horizontal distance. And that tells you your slope. That tells you rise over run. And in this case, it's not so much rise as it is fall over run. Because from this point to this point, I fall 1, 2. So since I'm going down, that's a -2. And then I run 1 to the right. So that's a positive 1. So the slope of this line would be -2. And since my line is going to be parallel, I'm going to use -2 in my equation as well. So here we go. Y minus y1 equals m times x minus x1. That's really a plus 7. So let's distribute and add, and I get an answer of y equals -2x minus 8. You could graph that to make sure that it's actually the right answer. If I start at -8 and I go down 2 and right 1, or you can also go up 2 and left 1, I would end up with a line that looks like this. And it also would end up passing through the points -7, +6, if you count all of your slope down and over, down and over, down and over. Therefore, it looks like I got the right answer. So let's write the equation of a line that is perpendicular to this graph that we see here and passes through the point 2, -5. So 2, -5 is going to be our x1, y1, and our slope, m, is going to be a positive 1 over 2. Because if this line has a slope of -2, that's what we just said on the previous example, and this time our line is going to be perpendicular to that, I need the opposite reciprocal of -2, which would be positive 1 over 2. So let's plug in our numbers, and distribute, and subtract. And this is the equation of the line that is perpendicular to the line that I see graphed here, and passes through the point 2, -5. And you can verify it by graphing it real quick. I would start down here at -6, and then I go up 1 and right 2, and here I am at that point 2, -5 that I was supposed to pass through, and up 1 and right 2, up 1 and right 2, so I end up with this line right here, which forms a right angle with the line that I've been given, and it passes through the point 2, -5. Our next example has 3 different points that we've been given, so you're going to have to read the directions to figure out what each point is actually going to tell you. The line passes through the points -4, 8, and it's parallel to the line that passes through the points -8, 5 and 0, -1. So this first point, -4, 8, that's going to be x1 and y1 when we write the point-slope form for our equation. But we don't need it quite yet, because first we need to know the slope of our line. And that's what these other 2 points are for. We're going to use these 2 points to calculate the slope of the line that we've been provided, because our line is going to be parallel to that. So whatever slope we get when we calculate using these 2 points is going to be the slope of our line as well. So let's do it. So this is going to be my x1, y1, and this is going to be my x2, y2. So I've got -1 minus 5 on top, and I've got 0 minus -8 on bottom. So on top I have -6, and on bottom, well, that's really just a +8. And that reduces to -3/4. So that's going to be the slope of our line. That's m, because our line is parallel to the one that we just calculated the slope of. And parallel lines have equal slopes. And now we'll be using this other point, -4, 8, as x1 and y1 in our equation. So let's fill out our point slope form with this x1 and y1 and this as our slope. So I get y minus 8 equals -3/4 times x plus 4. Then I'll distribute. -3/4 times x is just -3/4 x, and -3/4 times +4 is -3. Then I'll add my 8, and my answer is -3/4 x plus 5. For our next example, we're going to write the equation of a line that is perpendicular to the line that passes between these 2 points and passes through the point -9, -2. So we're going to repeat the same math that we did on the previous example to figure out that slope is -3/4, except this time we don't want to use -3/4, because if our line is going to be perpendicular to this one, then I need to use the opposite reciprocal. And the opposite reciprocal of -3/4 is +4/3. So that's our m, and -9, -2 is our x1 and y1. So let's fill in our numbers and simplify. So I have y minus y1 equals m times x minus x1. Again, this is really a +2, and that's really a +9. So let's distribute. I get 4/3 x plus 12, and then subtract, so my answer is y equals 4/3 x plus 10. And finally, we're going to use a table to help us calculate the equation of our line. Our line is going to be parallel to the line that's represented by this table, and it's going to pass through the points -4 and -1. So again, the first thing I need to calculate is the slope. And keep in mind that when you're given a table to represent a line, you're actually given too much information. You only need 2 points in order to calculate the slope of a line. So you can pick any 2 points that you want to from this table. And personally, I'd rather not deal with decimals, so I'm going to use the points 0, -7, and 2, -6 when I calculate the slope. So I've got -6 minus -7, that's y2 minus y1, over 2 minus 0, that's x2 minus x1. You would get the same thing if you used either of the decimal points. Just make sure that you're subtracting y's over x's. So let's simplify. -6 plus 7 is 1, and 2 minus 0 is 2. So the slope of this table is 1/2, and since my line is going to be parallel, I'm also going to use 1/2. And I'll use -4, -1 for the x1 and y1 when I fill out my point slope form. So let's fill in our numbers, distribute, and simplify. So the equation of the line that is parallel to the line represented by this table and passes through the point -4, -1 is y equals 1/2 x plus 1. And finally, let's write the equation of a line that is perpendicular to the one represented by this table and passes through the points -6, 5. We're going to use the same math to calculate our slope of the table. It's still 1/2, just like it was last time, except this time, since our line is perpendicular, I need to use a slope of -2, because that's the opposite reciprocal of 1/2. So using a slope of -2 and x1, y1 as -6 and 5, let's plug it into point slope form. So I have y minus y1 equals m times x minus x1. So distribute and add, and our answer is y equals -2x minus 7. And that's all you need to know about writing the equation of parallel and perpendicular lines. In our next lesson, I'll be giving you lines, and you have to determine whether they are parallel, perpendicular, or neither.